Hello, this is my recording for Homework 3, Part 1. Part 1 asks for us to draw a diagram of the problem, highlighting and explaining the important variables, concepts, and relationships. So what the problem is a container initially open to the atmosphere is filled with 1 kilogram of water with the contents initially at 298 Kelvin and 1 bar. The container is sealed, then heated to a final pressure of 2 bar. Determine the final temperature and the total volume of the container so that 0.3 moles of water are in the vapor phase. So what we'll start off with is a drawing of the initial thing, and we have our H2O in here, and then what we are told is that we are given a mass of 1 kilogram of water to start off with, and an initial temperature of 298 kelvins, along with an initial pressure of 1 bar, which is also equal to 1 times 10 to the 5 pascals. We just do this because pascals will be used later for equations, not bar. So then, after this, the system becomes closed. We still have the water, heat is applied, and then we have our new information. The final pressure is 2 bar, and same thing back here. 2 bar is equal to 2 times 10 to the 5 pascals. And then it also tells us the moles of water in the vapor phase. So that is equal to 0.3. And the stuff that we are trying to solve for is the final volume and the final temperature. So the way we'll go about doing this is creating an equation for the pressure system, the entire pressure system. So we'll write PF, meaning final pressure, which is what we have up here, is equal to the pressure of air plus the pressure of the water in the vapor phase, and that is equal, like I said up there, to 2 times 10 to the 5 pascals. So we have one equation, but we need a second one. So the next equation we're going to write is for the moles in the vapor phase. So we'll write that out here, just like we have up there, and that is equal to the partial pressure of water multiplied by the volume of the vapor phase divided by RT, and this equation is derived from the lovely PV equals nRT, our favorite equation, Pivnert, and back to up there is equal to 0.3. So now that we have these two equations with two unknowns, which are these ones right here, the final volume and the final temperature, we're gonna go back to our first equation that we wrote right here, which is final pressure is equal to pressure of air in the system plus the vapor pressure of water. That's equal to the 2 times 10 to the 5. And next, we'll go and create a new equation for the pressure of air, which is the moles of air. This is from our Pivnert as well. We're just deriving it from that, times RT, all over the volume of the vapor pressure. And then we are adding the vapor pressure of the H2O times the temperature. That is equal to the 2 times 10 to the 5 pascals. So next, we know that N air is equal to the initial pressure times the volume of the vapor pressure over R, and then the initial temperature. And then we can get the equation for the vapor pressure over here, which is equal to the final volume minus the volume of the liquid water, which we can calculate that from taking the mass of water and dividing it by the density of water. So then the way we solve for this is by using this up here, and then we go back to equation 2, this one right here, called equation 2, equation 1, and then we have this one right here, which is equation 2, which has the final temp in it, and then, this one has the final temp, equation 1, and we use these two equations in GitHub to solve the problem. So that was part 1 of my video. Thank you very much.